Bernoulli's equation, physics grade 10. So Bernoulli's principle states that the sum of pressure kinetic energy per unit volume and potential energy per unit volume is equals to a constant. It's the pressure plus kinetic energy per unit volume plus potential energy per unit volume is equals to constant K. Therefore, but we know that volume is equal to mass over density. Therefore, kinetic energy per unit volume is equals to kinetic energy is half mv squared all over volume. Volume is equals to mass over density. Is the same as half mv squared multiplied by reciprocal of this here is density all over mass. Mass and the mass goes. All this is the same as a half density v squared. That is kinetic energy per unit volume. Therefore, potential energy per unit volume is equals to potential energy is equals to mgh all over volume, which is mass all over density. Therefore, this is equals to mass and the mass goes. This is equivalent to density multiplied by g multiplied by height. Therefore, potential energy per unit volume. Therefore, the Bernoulli's equation is equals to pressure plus kinetic energy per unit volume, which is a half rho v squared plus potential energy per unit volume, which is equals to rho at g na h is equals to constant. This is the equation which is used. Remember for Bernoulli's equation, we see that liquid is incompressible it is also non-viscous. It is non-viscous and its flow it's streamline. So for the Bernoulli or the flow meter, there is the Bernoulli meter. It is a device used to measure volume, flux of fluid. Well, we know that C is pressure plus a half for viscount is equals to constant, because potential energy it is for for fluid in the rest, but this is not at rest, therefore it's half. Therefore we cannot add because the fluid is moving. Therefore it's like this is, if you are given this at 1, at 2, there is area 1, there is also pressure 1, there is also A2, P2, also velocity, also V2, so V1. Therefore P1 plus a half rho V1 squared is equals to P2 plus a half rho V2 squared. Same as to say P1 minus P2 is equals to a half rho V squared, which is V2 minus a half rho V1 squared. Therefore P1 minus P2 is equals to a half, then rho, this is a common factor, multiplied by V2 squared minus V1 squared. In volume fluids, we know that A1 V1 is equals to A2 V2. Therefore V2 is equals to A1 V1 all over A2. Therefore V2 is equals to A1 V1 all over A2. Is it like that? Yeah, like that. Therefore V2 squared is equivalent to that. Is equivalent to this squared. Therefore P1 minus P2 is equals to a half from square bracket. Therefore this is same as A1 all over A2 squared multiplied by V1 squared minus minus this one V1 squared. Therefore this is same as half from then this is a common factor. Therefore V1 squared all over A2 squared minus 1. That is the equation which is used.